shall I put it in scale? It being my new idea, potential energy or kinetic energy or whatever, height difference basically. See description. It's kind of a scale thing. No, it's not. Damn it. Where shall we put it? It's a matter of renaming scale. I can put it in here. Maybe I should not put it in here. Maybe not. Is it related to? It would be related if it uses a scale, I think. I think I might be using I should be using scale maybe to determine the damping. Dampening, what is the word? Kind of do want that. Yeah, I could still put it outside the class. Just call scale for the damping. I don't know. Maybe start a new class. What shall we call the new class then? Well, let's call it class. If I call it momentum, then everyone will know what I mean. But I don't want to call it momentum because really it's just the, the kinetic energy. That would be more like the square of the momentum. I'm going to call it kinetic energy. Excusez-moi. No doubt I want to be able to print this thing. The forever boring thing. You don't need debug, and if print on standby in reference, so yes, const. Just print height difference. Yeah, well, automatic conversion to double or not? I don't feel like calling it a height difference. Now we have reached the accessor, and suddenly I don't want to call it height difference anymore. Why not? This is one of the more annoying things of the object-oriented coding, I think. You make an object type kinetic energy. And I'm currently in the habit of calling it kinetic energy in that case. So probably not the best thing to do. But yeah, that's what it is. That's why I called my class like that. So that's already called kinetic energy, and then I want to get the value of this just to wrap around a single thing. So yeah, what the hell does one use then as accessor? You want to convert it back to a double. You get the value of it. So yeah, maybe just call it the value, but. Though I could have an so in main I would have kinetic energy and then kinetic energy. And then I want to have the double value of that. So you can do can do that automatic conversion. Yeah, or that with the parenthesis operator, or that, which looks kind of silly, but yeah, you can abuse all kinds of operators. Or you can of course do value, but that's a mouthful. I mean, what do you mean value? You know, it's kinetic energy is kinetic energy. Why would I have to say value? And then worse, because that's what we started with, I thought the accessor could be called height difference. Yeah, hello. So then you got this height, the kinetic energy height difference. And although that is what is returned, it is the height, pure the height difference. But yeah, now I can fill a book with this variable name or function name. So for scale, I went this way actually. Just call it scale, and then if you try to use it where a double is required, then it just automatically converts to a double. Yeah, maybe should do that here too. It's often not a good idea because then you get all kinds of accidental conversions. But if I don't make a mistake, and I'm inclined to think that you should not really write code such that. Well, no, I'm not sure. Usually, I'm inclined to write code that where it is impossible to make mistakes. So it's definitely not true what I wanted to say. That would be type safety in this case, meaning that you'll just pass kinetic energy to every function that needs it instead of a double. You know what? I think I don't need an accessor at all. I'm not interested in the exact value of the height difference. I'm interested in if something is larger or smaller or larger than. Yeah, so I want to do it the other way around. I want to be able to convert a height difference into a kinetic energy and then compare that kinetic energy with this one. We can do that in one step. I can make a boolean and say less. Yeah, let's just make an operator. Operator less. Is this kinetic energy less than this double? So you're not really accessing it directly then and then do the compare, but just pass a height difference that I must have anyway. Because the only reason I would access this value is to then compare it with another double. So I might as well pass the double to the class and then get my answer. Yeah, now I can only test if the current, the kinetic energy that we have is less than a double. No, that's good enough. Maybe the other way would be better though. Okay, let's add the other way as well. It's kind of better anyway. At least now I can't even make the mistake to try to compare to equal, which is usually nonsense. Usually nonsense for doubles, but also in this case, of course, I'm totally not interested in ever know when it is equal. Yeah. Now I can even add more code to allow me to compare larger than as well, but that would be pure laziness. I'll leave it like this, I think. Now, what more do we need? We need updating, of course. So I have a certain kinetic energy and I want to update it because the ball dropped down. I'm actually calling it ball now. Or up, of course. Maybe I don't even need these things. I can just add an update, which then returns a boolean if we went too far or not. Okay. I think I should allow to go too far. Create energy out of nothing. Yeah, maybe this is actually better. So I just do a boolean and then update. It's kind of like the skill. Let's call this height increase. So it should be negative when we are going down. use that for now. Then what we do is we multiply the current height against the current energy with 0.9. And then add, subtract the height increase. Now if we do overshoot, then well, we kind of have reset it, or should reset, I think. So I'm gonna sneak in an extra energy then. So that actually, suppose we are in a valley and we start at some height. So every step that I take, I divide by 0.9. But if my steps are super large, I might overshoot like an enormous amount. So even though the energy is per step is 90% of the previous height, it can still overshoot like enormously if the step is really big, and the step can be arbitrarily big really. So overshoot will happen, and then the energy is higher. And if then I set the energy to 0 again, and we go back and the same happens, then well, that won't happen because I don't go back. But it's theoretically it could indeed go uphill forever if the terrain is such that we overshoot all the time. But negative energies don't exist, so yeah. Tough. Let's rename height difference. Sure. That's definitely problematic. Maybe I should refuse the update. At all. So the whole, this, then an overshoot is no longer allowed. Yeah. Yeah, I don't want to accidentally increase the energy to infinity. So let's just not allow overshoots and then see if we can make that one work. Which means that if the overshoot happens, then you have to undo what I just did. I'm going to return I guess success. And then I wish I had not done this. No, just the new high drop. This is calculated, so times error minus height increase. Right, now on top of that, it is just super annoying to pass a height increase here, I think. I would rather just pass the height, period. But yeah, I really need the height increase, so it's more like you need the height increase since the last time, then, or more or less. Although I'm not sure about that, but for a start, I'm just going to have to start with the height, the current height. And although I have called it height everywhere so far, everywhere else I'm calling it LW. So I think I have to rename that now. So after dropping height drop, we are at LW. And this I probably don't need, right? It is not that easy, is it? Shall I leave it in? So highly dubious that I need it. Put it here now, but don't have to type it again. But I'm going to comment it out. And the update, I'm just going to do new height. And the new height means that the height increase is a new height minus the old height. And then let's just rename this again. New LW. Yeah, now, well, maybe. So let's create this object. I need an initial value for the height there then, before I can do this. I think that is the first sample, which already said here. Sample itself can be called, which delayed calculates that stuff. So let's put the height here. The kinetic energy. I'm gonna call it KE, I think. I hate abbreviations though. How about I just call it energy? Momentum. Yeah, oh. As a physicist. From a programmer standpoint, I could call it momentum, but as a physicist, it's just different units and everything. Let's just not go the abbreviation way. I'm gonna call it kinetic energy. That has to be initialized with LW. I really need to have different types for all those things. Everything is a double now. It's not type safe at all. That's what I mean. You know, LW is the height, which is double. W itself is also, as the I don't know, the change in the weight, it's also a double. So I accidentally type that, it will compile, which is quite unacceptable in my eyes. So I should use a wrapper for these things. It would still be double, same assembly code, but at least then you can't make that mistake. Well, you all know that the kinetic energy is 0, so the only thing I can print here is the height. So maybe I should change the print. Of course I should change the print because I added the height to it. Then I'm going to print it as the height. It's not really a drop anymore because I multiply it with eta every time. It is the energy that it is left, so this is kinetic energy. But in terms of height, I'm gonna call it just energy, dude, because it's both potential energy that is now converted to kinetic energy. So it's both. Energy is just, conserved anyway. A measure for the energy that is left over. Possible that it compiles, you know that. First attempt, okay, amazing. No, well, not really. Initialize fields. Oh. Oh. Oh, I have to pass the function L. Because it's not initialized. I knew that. No, I didn't. What the hell is it with the line number? Don't have a line number anymore. Okay. Well, I bet I have L here. I'm just passing L in the hope that you have it. Oh, you have it here. It is L. Also pass to the history. Okay. So I printed this. Initial height is 41.6 and with an energy of 0, obviously. So that would be this point where we are now. And then the next step, the height has changed to that. And now I have to call update, of course. Whenever that happens. I'm pretty sure that this is wherever a new sample is changed. So we can look for new sample updates. And then change the kinetic energy as well. New sample. Yep, right there. Okay, new problem. I don't reject this. I don't care how hard it goes. This goes to a new extreme. That's what I was looking for, and I really don't care if that takes more energy than we have. I'm going to pass new sample dot LWL, but if that returned false, then I didn't update anything. Kind of want to force it to update it. Yeah, this is another one. This again, and just do it. The skills updated. I think that's the right place to do the kinetic energy then. This is more dubious, because that could be like way too much, I think. Or can it? Yeah, let's just do it as well. It's more the keep going thing that I'm worried about. Should be worried about. All the others are just do it. Update it. Period. Yeah, let's increase the energy. Why is my scale not set here? Because I'm going to override it anyway, I guess. This, for example. Or not. Actually, also not. Hey, Mooch. The chess segment. Well, how many views do I have? 3, yeah. Usually when I get tired. Is my rating still over 2000? Because I think I did climb a little bit higher. My rating is now, I don't know. Yeah, 2009. How about that? I did increase. Okay, I play one game because now I've started it. That's a weird move. It kind of belongs to the dragon, I think. And we are not playing the dragon. So now the bishop, dragon, bishop goes here. But I think in this case, bishop should have gone here. He's just not challenging this square at all. In any way. So I guess you just should do this, right? And then stop the bishop from going to the ideal square. No, I can also do it like that. So normally then you put the queen here, pawn up, bishop here, but yeah, no, that's like concrete. So maybe I like it more to put it there at the moment. This is also a weak spot. I'm gonna go here anyway. I think this guy is, it's so annoying. This guy is playing the wrong opening against what I'm doing, but I don't know how to punish it. I'm also just playing my opening more or less. Maybe should have went for this weakening here somehow. So the queen had should have kept an eye here. Nah, not likely. The bishop here could just retreat retreat the bishop. I'm gonna go. See, this guy's a complete idiot. He's playing like I have a dragon, so like my pawn is here, bishop is here. Then he wants to play the bishop, guarded by the queen there. He's going to castle long even, I think. Seriously. Do it. It's already starting the attack. Now, I guess I should develop further. I'm gonna go that way anyway. It should be possible. Tough decision. Castle long or short? This guy also didn't castle yet. I decided not to castle long anyway. Running out of time as usual. I'll probably lose on time. That might be a weak square here. The bishop goes back. If I thought this and I want to take like that. Take there, take there. I like my open file though. I'm gonna do it anyway. Let the bishop come there. I don't think he's in time to double here. Let's just go up. Yeah, this looks horrible for white. Devastatingly horrible. And I'm up in time again. So if I lose this, it would be really, really bad. Come on. Possible. Possible to lose this. This defense move is also super bad. Would have been better to go there. So now I can take here. I probably could still do that if could check. I could put the bishop here, but nah, and then the pawn comes. Nah, that would not have been good. Now the bishop gone, I can put my rook back. So, totally safe. Bishop is now pinned. Yeah, I was threatening to take the bishop. Yeah, I'll just round it up. Round everything up. Not a pawn. Suppose I should play this pawn. Let's not allow this queen to enter. And now he allows me to give check. I think I'm going to bring my bishop into play. Although now he has a check here, but I can always put my bishop there. Okay. Convince me. Convince me that this is not made in 3 moves or something like that. Okay, well, I guess he just ran out of time, more or less. Interesting game, but oh, this is how we play these days. I even win online. I even win while streaming. Can you imagine? Do I have a graph? I wonder what my rating has been. No, just going up. Ish. I've been over 2,000 before. What is it? In years? You're gonna be kidding me, no? No, wait a minute. It's... Nah. I've been way over 2,000 here. 2050. This is Blitz, right? 2013. In 2024. It's maybe the highest I ever got then. This looks higher. 2051, yeah, it's higher. And again, I think 2050 is the highest I ever got on light chess. So I have to go over that before I can say that I really got stronger. And my puzzle rating is absolutely horrible. going down here like crazy. Puzzles 2331. It's more than 100 points down in the last few weeks, 2 weeks. Yeah, well, for a decade at least, I played 5-minute games every day for hours. I just went to a chess cafe and then played people. Did that almost 7 days a week. But yeah, as I say, you don't learn anything from it. So the only thing I saw change is that in the beginning I was like constantly dropping pieces. And at some point, after thousands of games of 5-minute games, then you start to get a feeling for not dropping pieces. So one 2-ply deep tactics. Yeah, they did sink in. But strategy, no way. New patterns, no way. You don't learn much. Yeah, I wish they had that in this neighborhood. There's only a few places in the world where you have those get-togethers on the street or in a cafe or somewhere. They're really nice. Very hard to begin one, I think. If it exists, then you can go there, but you could ask the gemeente, what is that in English? City council or something, to make a big chessboard here or something like that, but nobody would show up. Nobody would show up. There's just no chess players anymore. Not in this neighborhood anyway. Yeah, seems like absolutely awesome time to spend my all days. Yeah. If you're somewhere in France where they have this nice square where everyone plays non-stop chess 24 hours. Well, maybe not 24/7, but definitely every day. And to live there and just play chess every day, that would be nice. How do we update the kinetic energy in this case? This is kind of like the first step, I think, or not? It's not necessarily the first step, I'm afraid. Okay, let's add here. And I'm just going to rename it, I think, to maybe update. In case that it returns a boolean. And for now, just assert that it is success and then see when it goes wrong. Yep, and these, well, these three also need to abort whatever they're doing. I don't have any code yet that deals with a failure, I think, except for a break somewhere that it just leaves the whole program altogether. Yeah, I don't know. Maybe assert is the best thing to go for at the moment. At least I have my update code in place then. Can we do something like plus or minus? Okay, that's silly. Plus or minus, and then a question mark? Nope. Why not? Destroying everything, but maybe you don't have a question mark. Oh, maybe we should have escaped that one. Look, that worked. And also the equals is found. It really worked. Okay, so changing new sample and then update the kinetic energy. And then change new sample and update kinetic energy. And here, change it and update it. And here, change it and update it. Change it, update, change, update. Okay, I think I have all of them. Okay, which shall seal? Oh no, someone called me old. This is the first time in my life that someone called me old. I think, well, yeah, it has to start sometime. I am old. Well, yeah, I don't know. Even in my eyes, right? Definitely old. I used to think that 40-year-old people are old. So, way older now. Time flies. But yeah, you can be way older. I see all those people walking around stuff slowly because they hardly can walk anymore. And I'm going to get there as well. It's just a part of what you say, and period of life. The last decade or the last 2 decades are not fun. Oh. Update sample. So this is really the maybe update, and then my update is might as well be void then. Nothing to do being old. I just have a bad health currently, it seems. Cough, cough. That's quick. I've got my my right back. Guess it is possible. Yeah, let's be lazy. should drink some tea with honey or something. That helped last time. Against the itch in my throat. Okay, so it wants to go to 29 from 25, which is a whopping increase of 4.7, say. Oh, we don't have that. 29.8. Let's see if I understand that. That's all the way here. No, that must make much sense. It should make a step of equal to scale. So that's like, is this like more or less symmetrical? Expect to get to this height here. 25. It's annoying that it doesn't print the value, the new value W. Was this it? This is it. Yeah. We are at the vertex, it's minus 7.75, and then we go 10.5 to the left. And then you end up here. That is true. Minus 18. Well, scale is 10.5. Minus 7. It's like, okay, I believe that. And now I end up in 18. And it's 18 something penalty that's here. Okay. The trick with the paper on the monitor, yes. That distance. That distance here. And then we go up. And then I end up where I said I would end up. A little bit over 25, not 29. What? 25. Guess I was confused with something. What did 29 come from then? Yeah, what? Oh, wait a minute. It's the update after that. So indeed, the 25 is correct. But doing two updates, so another update here at 29. That one is disallowed, rejected. Yeah, okay, I just should run this thing with in the debugger. No, I shouldn't. What? Oh, right. Wait a minute. Ah, okay. Yes. It's like we're crashing at a different spot now. Nobody gets it. Nobody gets it. This is line 1064. Don't tell me that this has been the same place or it crashed all this time. What's the best way to lose your scroll back? This is the first place, 1059. Yeah, it's almost the same place. Just added some code. Well, okay, so I was mistaken. It was here that we crashed. Yeah, oh, okay. What we need is a way to stop it, this nonsense. To keep going nonsense. Let's not keep going anymore. I'm gonna do this one first. It seems easier. This one is a random step. And then it turns out that the step is too big. Seriously. So it kind of would be nice to combine these two things in one line, because now I have updated new sample. Yeah, well, that's an exception, isn't it? This, of course, doesn't compile. It's also extremely annoying. I'm going to put it all online. Door. Up. You've not success. Yeah, okay. Undo. Yeah, but not really, of course. No, what we wish then is that we reduced the learning rate with a half. It's kind of a backtracking thing, isn't it? So it subtracts learning rate and then that's not possible. Therefore, I want to add learning rate again, but I might as well immediately do the new test after that and not first add it and then divide that by 2 and then subtract it again. Not that it costs CPU, but it just looks a little bit silly. This would totally work. However, we might as well do this up there. Then define success this way. What, really? Not in the loop. I can make it a while though. Okay. While not success. Learning rate halved. New sample added. So because I'm assuming that this only happens once, that definitely should not happen again. If you have 2 random steps after another. I mean, no, yeah, no, rather if due to this action here, this while loop, the next thing is that we need another random step. That seems impossibly. Seems impossible. But yeah, in the end, everything is possible, of course. So assuming this only happens once, then I'm subtracting the learning rate. And if that didn't work, or is not allowed, or whatever, then we backtrack half that distance. And then we try it again. If that's rejected as well, we make the step even smaller. So every time halving the step, basically, because yeah, I'm adding half back until it succeeds. And then we still have this. Which then hopefully gets us here and then make this fill and then we abort. But what happens if I would get back with a random step again? Then I also have to abort. I think it's not possible at the moment. No, it's not possible. I'm adding a new. This only happens when we have one measuring point, one sample, and after that I have two samples. So now we get here, and then we get here, and we add a second sample. So definitely not going to be another random here. This whole loop is never going to happen anyway, but well. Add a comment. Extremely unlikely. Impossible. But I might as well assert and tell the user to fix the learn grade or something like that. That step's too big. Oh, wait a minute, I'm adding this comment, but now I realize that that's not true. This especially happens when you start in the minimum already. So you don't have any energy whatsoever. The energy is just, it's like zero. Whoops. We don't have any energy. Oh boy, yeah. So no, I can still not climb out of it. No, this must not be rejected. This must never be rejected. I'm finally seeing the light. This is not what I want. What I want is to force this one. Update. That's what I want. Completely turn around here. Now suddenly it's likely. Yeah, it's kind of stupid, right? Because now we have almost no energy because we started super low. And then I do fit a problem which then has its vertex in where we came from. So that's going to be keep going in one direction, and we still hardly have any energy because just one little step has been done. So by adding this energy stuff, this breaks down. This code was added yesterday, especially for when you start in the minimum already. But yeah, how far to go then? Yeah, I don't know. How far to go? A lot starts to depend on where we start now. So if we start on some hill and then find a minimum, then we have a scale. That depends on where we started. If we start in a minimum, the scale is tiny and you never get out of that minimum, period. There is no way to know how far up you could go. It's really, I literally need a random step, but we don't have energy. So I force it. I better take a big step, I think. Otherwise, learning rate might not be enough. Oh man. Maybe make an abort counter. Like I could set here on the do not abort for the next 3 steps or something like that. And then continue. So then we get here and then I would like to abort because you don't have energy, but I don't because this thing told me not to do that. And then at least we build up something. So it takes 3 steps in some direction and then we have energy again. At least something. So how many maybe updates do I have left now? Is this the only one? There's another one here. 2 left. What about this one? Treat this one as keep going, I guess. So it literally says so in the comment. Keep going the same direction. So if somehow I can break out of this scope here. Is that possible? I would have to go. Yeah, here. So leave this scope. Doing a break does not apply. I have to add a lot of else's. You can do an else here. So I can just leave the scope. No, wait a minute, that was not. This has to be done anyway. I'm already leaving the scope here. It's kind of like the keep going thing, actually. What is that set to at the moment? It's a step kind. So at this point, what is step kind? Done. Is that true? Being set to done there, and then yeah, then we get here. It's totally set to done. So now I want to not do this, but simply set step kind to step kind keep going. And then don't do this, but get the same effect, namely subtracting scale, once we get here. Yeah, which is kind of lame, I have to admit. Because it uses the derivative at that point. I don't have a derivative. I'm pretty sure my derivative is 0, namely. Ugh. It's a special kind of keep going. No, we don't want that 0. Shit. If it now is rejected, I mean it was already updated. So I have to undo that then. Why is this not highlighted? I have a W here. No. So now I postponed the abort, but at least handle the reset of the new sample. The kinetic, if there's not enough energy, then the sample is set back to what it was. And I request an abort of whatever you're doing. And then we get here, and I have to implement this still. Poo-poo, okay. Totally have to add a board now. And then yeah, the other stuff that I just horribly changed. I have no idea what that is. Yeah, it's here. Yeah, I added these things. So what we can do is not this anyway. Kind of the same thing here, right? So we need to keep a copy of W, new sample W, adjust it, try to fix the kinetic energy, and then if not success, set this to abort and set a new sample back to W. Yep, and then as a result of setting it to abort, we don't do this and we don't do that. Therefore we go all the way here. We don't do this. We don't do that. We just go straight to here. And then now this is the only place where I need to implement the code for aborting. Yeah, I think this quite literally means abort going in the current direction. However, no, not the vertical direction, the horizontal direction, which depends on the variable W delta, which is annoyingly set to 0 still if we abort from here. So what the hell does that mean? Yeah, and then I discovered that I don't want to abort. Oh boy. This is more like the random step. This kind of random. I just randomly take a scale step. Yeah, I shall not abort you. Nope. The whole aborts thing was wrong anyway, because I have to do this. We did find an extreme, and I have to store it. And this is my current abort. Oh boy. This is what I don't want to do. Do want to do this part. Okay. Is this really true? Yeah, this is true. Yeah, it's totally true. It's just, it's a one-time thing again, because if it is 0, I'm setting it here. So, well, a one-time thing, just do it. Not maybe, it's just update it, period. Mm-mm. Hmm. Yeah. Yeah. I think it's a bit fast though. It is rejecting it a bit fast, isn't it? On the other hand, maybe it isn't. I mean, I know this is a parabola that goes up to in infinity, but do we really want to explore this outside of the graph? Might as well say, dude, you came in here, this is the graph, that is the minimum. I'm totally happy that it rejects going up higher than 30 here. Yeah, well, you traveled the whole graph and then there's still no minimum here within this graph. It's like almost at the edge. It's like the perfect point to stop. The only problem is, I think, that if I start here, then what happens? But I can test it afterwards. Let's write a code to board this in going into this direction. But with using the same energy, I don't have to go in that direction either then. I mean, that's where I come from. But just done completely. In this case. But okay, only because... Are we done completely? Kind of, I guess. So if we started here and then continue till there, then it makes sense to go back and see if there's maybe, a bump here that we can go over and then find another minimum. If we started here. But if we start here, then then we export everything. If I stop here because of the height, then there's no reason to go back to zero, of course. So it's again super depending on the starting place, it seems. For example, if I start at -5 here, then we'll jump immediately to the vertex and then reject going higher than this point and then stop. Then we only explore this part. It is not good. It's not good. So it could be a minimum here that is lower, as well as on the other side. Abhishek Singh, hi. I'm trying to find a way to optimize the gradient descent algorithm, and I'm doing well. Just all those edge cases are difficult, especially the scale is difficult. You just have to, you know. I mean, this is a bad example by now. But if you have a minimum here and you have another minimum here, which is lower, then you could say, well, if I start here, then I just find this minimum, and then we roll through, and we find that minimum. But if you start there, then we don't have the kinetic energy anymore to come there. So we just go here and I say, okay, it's too high, let's go back. This was the minimum. And I don't like that. I mean, why would I stop? And the starting point is random. This one is deeper. Block. So even from the get-go, you need yeah, I would say energy. Maybe we should allow to pass an amount of energy. Let's say I just give it 50 energy. It's the height of the whole graph. I'm going to do that. We need a starting energy, no matter where we start. If you get what I mean. This is not good. I don't want to start at the wherever I start. I want to initialize it with an amount of energy, being L max. I think this is way better. So now we go here, and now it won't stop. It's no reason to stop here because we can go back to 50. So 30 is not the point where we stop. Yep, now it continues. But it didn't find a maximum, so we continue. It stops. Why did we stop now? Because we did not reach 50 yet, but we lose energy every step. So by now the amount of energy we had was 29. So it got down fast. But okay, if now say the other problem, if I start super low, is solved. It doesn't matter if I start here. Might as well start in -5, and it will still go all the way up till the 30 point. Probably even higher now. Because yeah, I'm there faster. One step less, so we go a little bit higher. Let's try the -5 thing. It should still do the same, more or less. start at -5. So now it goes to 4, 5 here instead of there, because the scale is less, because it doesn't know that it is a big problem. It only sees this part of the problem. But then we can get going, and it still goes up high. Okay, it didn't go higher than that because that was already a lot of steps. So losing 10% of the energy every step. So now couldn't reach 30 anymore. But again, I can set the damping less, and then we can go all the way up till 50. It's maybe a nice experiment. What have I set the damping to? So we set the damping almost nothing, almost no damping. You start at the bottom, and then you have a lot of energy, so we go all the way up till, and we don't. Oh, it wanted to go to 100. Is that true? Yeah, the new element. That's a lot. That's a lot, man. 116 is kind of ridiculous. I'm currently multiplying the learning rate by a factor of 2 every step, thinking that it might be logarithmically necessary to grow, because I don't know how high to go, but I will limit it tremendously high how we can go, actually. So I'm not sure anymore that learning rate should be doubled. It's a more just in case thing. Yeah, no, maybe anything will do then, because it's going to be an exponential growth anyway. Is this the point? I think I have another point. This is the point. No, that's a random one. And random only happens once. I'm removing that completely. I thought I was doing that here. I know I don't see it. Is this the only place? Yeah, because this is the place. Let me make this 1.2 or something. Maybe it should be 2 minus eta. Wait a minute, that's nonsense. It's like comparable. Increase it comparable with the eta that I use. That would mean that if eta is 1, then we don't increase it at all. That's nonsense. I don't know. Maybe they're not related, probably. Yeah, it's considerably slower. Yeah, that way, yeah, it just does take a lot of steps, more or less. I think I don't like this many steps, but we're not really sure what we're doing. No, I guess this is reasonable. It's kind of exploring the height here. We don't know how high it goes. I just know that the maximum height that I want to go to is 50. Reducing every step, by the way. Maybe the maximum height is now already reached. 35. You could in advance say, I want to take at most this many steps. And then you can do an nth root of the distance to the maximum height. But really, that's kind of random anyway. It is kind of random. You don't know how intricate the little bumps and details here will occur at some point. Yeah. Oh, I don't know. I'm going to stick with this, I think. Now I want to draw the energy that we have in this thing. We have the scale already. I think I can just print the maximum, and then you just know, well, in 10 that is the energy. In 9 the energy is like way larger, and so on. And although every step that the ceiling then gets lower, so the energy here was higher than it seems to be. You could draw a horizontal line and then have the same label with it, so you can see what the energy was that belongs to that point. Or I can draw a vertical arrow, 2 arrows from here, arrow from 4 to from 5 to whatever the maximum height was that belongs to that. Also, I should increase the scale, I think. These things are still the same problem. So the scale should be increased. I could draw a rectangle. That is the scale. And then the height is the energy. Maybe. Then we also have the history of the scale, so we know which minimum the scale belongs to. I don't know. Now I'm gonna go for a single line just with the scale at the moment. So I want to draw a horizontal line that updates automatically every time the energy is changed, and this line is part of the scale object, so I might as well make it part of the kinetic energy object. So I have the class scale. I'm going to steal copy from it, steal code from it. Yes, still this as well. Still everything. Yeah. Private functions, put it there. Call it whenever it is updated. And then we want to draw, well, let's see, begin with the text. I'm having text, plot, scale text, whatever. That's going to be energy text. I'm interested in being a king billionaire. Forget king, just billionaire is good enough. Energy, well, it's not like you look at a random piece of code and then understand it. No way. It's a language, so what you can understand is see that, well, this must be a variable and it's being assigned something. Okay, this is an object and I'm calling a member function on it. But for much further you cannot come with understanding. Okay, the place where this is being drawn is in the middle of x1 and x2. At the height, scale y. That's totally not correct, right? I need a line at some height. This is just going to be the middle of the plot. I think. Yeah. We have a plot, so plot. And then I think my x range gives me point coordinates. And then I must have the middle of that. So basically it's min plus half of the size, or min plus max divided by 2. Either way, you have to call it twice. Min plus max. So I don't think I have an x and a y, but I have a, sorry, I don't have an x1 and 2, but I do have a y, which is then kind of simply the height of my energy. That's just that value. Yeah, whatever. So let's use that as the scale here, as the y coordinate. Scale. Programming and language is clearly something different. The y coordinate is LW, and then I will need to draw a horizontal line. Okay, we have only one line, so I can delete one. I'm going to draw the horizontal line, plot a line through some coordinates. Direction is up. No, because this is not a very vertical line, it's now a left right thing. Direction doesn't really matter. Say left. Okay, I'll say right. And then add that line to the plot. This layer with dashes. Do I want dashes here? No, not really. Sorry, the other one was probably better. But it's just using indicator style. Very lame. Oh, here as well. I have an S indicator style. Okay, let's use that then without the dashes. I don't have it yet, but I can copy it. It's just a default connector style. Well, whatever. Let's copy it anyway. Put it here. Oh, and then because it's a static thing, I have to do that as well. Silly. And then we have a line width of 1. Finally, there it is, the line width that I wanted. Okay, so where were we? Yeah. So now we have a line. The thing is now plot vertical line through. No, I'm going to add what we just created. Plot add line to layer with that style named plot horizontal line, which we defined here. And that is a line through a point, and that is horizontal, and that point is, so I don't have a parabola or a scale Y. It's kind of the same thing as here, but there is no need anymore to specify anything. I just 0 is good enough. As x coordinate, I mean. Any x coordinate will do for horizontal line. And the height is that one. Now, then we need the indicator is a connector here. Do I want to draw that? Do I want to draw that? It's a good question. So that would be a line piece with 2 arrows on both sides. Let's just not draw that. Let's do the text afterwards. Soon I will have some graphical output. Soon being as soon as it compiles, which is right now, of course. Make, and then run. No energy. That's my energy. And it's drawn at that height. Yeah, of course. All my labels are through in one another. Maybe you should put energy here, not in the middle. Energy is super low. Okay, but I press space bar. Now energy is 0. What? That's ridiculous. That's not good even. Okay, I'm currently drawing it at the last height. It just follows the line. My energy is now going through 5. It follows the points, I mean. So the last point is 5, and that's what the line is being drawn. This is not useful. Not useful at all. No. Sorry. Yeah, that's the LW. Why would I store the height drop? Might as well store just the height, period. Yeah, I'm going to rename it. Okay, I'm pressing my key and nothing happens. My keyboard dead. Mouse is not dead. Keyboard is not dead, that's good. So it must be something with this console, this tab even. VI has stopped reacting. What the fuck? Okay, just don't have time for this. Close program. Process is still running. No, it's not. It's sleeping. How the hell can this thing be running while I kill the terminal? I'm getting pissed off. Let's try a normal kill first. Still running. Now it's defunct. Oh. Something horrible went wrong. The Z is a zombie, so I'm gonna ignore it until the next reboot, I think. What the hell is going on? Okay, so the height drop. going to call that the max. The maximum value of LW. Is that reasonable? The amount of energy is stored in terms of a height difference. Amount of potential energy was converted into kinetic energy. But this is definitely no difference anymore. So yeah. I'll just have to remove this, I think. So this is the maximum height that could be reached with the current amount of energy. Kinetic energy, I guess. Current height. Just like this. What to do with the formula? So the kinetic energy is now max height divided by current height. And that energy is being reduced by multiplying with eta. And then I add to that the height drop that would just occurred. But I never want to go below 0. In other words, height drop is actually this. But I want to update the max W here, so this must be, well, that's the old LW, right? So add LW, And then if I add LW to this, I mean, you could do it outside the mux, but I might as well do it inside the mux. I don't want to go lower than LW. Worse than, yeah. The maximum cannot be below where we are. And then I still have to add it as well to this, which means that I just should not subtract it, I hope. That doesn't work. Okay, maybe do it outside then. Proportional width, but let's forget about that. I think that's correct, isn't it? The maximum height is the current height plus the kinetic energy that I have, which cannot be less than 0, and is the kinetic energy that I currently have reduced to something plus the height drop. But it doesn't feel good. Why does it not feel good? I don't know. I think this should be new. I mean, I just don't know. It doesn't feel good, and if I do this, it does feel good. So going by feeling, it should be new LW, but don't ask. It's like, because I set LW here, then at this moment here, so after I did both, then the kinetic energy is this max minus that, so I mean, this is what it says here. Since I set that to that, so then this is the new kinetic energy, which is then basically the old kinetic energy plus the extra energy that was just added. I think this is correct. And I have to do that here as well. It's not the current height drop. It's the, let's say, the new kinetic energy. Which is in this, but then without a zero max. So it's just this. I think we don't need all these formulas here anymore. We inject it because we don't have enough energy. Damn it. We have reasonable energy. So that would be 90% of the 50 that we were that I started with, right? And then every step it's reduced by 90%. Looks like way more than 90%. Why? Well, because it already ate some energy, maybe? No, that's nonsense. Doesn't matter. That's the maximum should just go down with 90% every time. So I did it wrong again. Definitely did it wrong. Yep. Being stupid. This whole part is bullshit. That's why storing max did make sense. You think? Don't even need to do the what? Oh boy. Okay, we're gonna have to think about this piece of paper. It's more or less the same formulas here, but it feels like I have to redo it. In a way, it's different. Why? Kinetic energy is the max minus LW. That's actually minus the new LW. Yes, where the max is usually updated like this whenever I want to ignore the standard max here. So it's just set to this value. So assuming that this formula is correct and the max is ignored or doesn't occur or whatever, max LW is set to this value, at which point it's set to this value, and then if I subtract new LW from it, that is the surplus of energy that I have. Is that the kinetic energy? Yeah, that's it. That's supposed to be the kinetic energy while being at this height. Now, let's say this is a line that I can understand. I just set LW to the newer W. This line, after having done that, makes sense as well, because if we have this much energy, then we can reach that height from this height. The height being energy in this case. I mean, it just, what is it? Gravity constant times the height or something. So, yeah, this makes sense, right? If we have positive energy, then we can get a higher thing, a higher position on the hill. This also makes sense because we don't want a negative kinetic energy. Now what about this line? So this is the current kinetic energy. We reduce the current kinetic energy due to damping. Then I subtract that from max LW. Basically throws everything away, the current kinetic energy. And then add new LW. Yeah, I cannot follow this at all. It's not correct. No, I think I should multiply this with 1 minus it. If add is equals 1, which means there is no damping, then this becomes 0. So then the kinetic energy is simply the maximum minus the height, the new height. That's going to be the new kinetic energy. So maybe I should use that word. That'd be new happy. Yo. When add is 1, so we have 100% damping, then I get that the new energy becomes LW minus new LW. Yeah, that makes sense. Let's work this out. Then I get main workout. I think I can simplify it. Yeah. The height drop is the additional energy that we just put into it. And then we add to that 90% of the previous kinetic energy. This reads at least as easy. Ejected, and I have to do this again. Okay, first we want to do the values, since they are still correct, of course. That is that, and then I say that times add up plus L dot. That's exactly what I have here. Don't tell me it was correct. What? Really? It's so confusing. Yep. Did I do that correctly? Going from here to there is easier, it seems. So that is, we should do the new height plus kinetic energy. Kinetic energy is supposedly that, which then simplifies to new LW drops away. How can that have, oh, nah, huh? Oh yeah, that has nothing to do with new LW, because it's just the maximum. So if eta equals 1, then this doesn't do anything, which is correct. And if eta equals 0, then yeah, okay, can live with this. But we still need to add the max back, because this thing is not allowed to get lower than the new LW. So I can just do standard max of the new LW. Like that. Mind-boggling. It is one line of code and it's almost not possible to get it correct, it seems. I think I'm just too stupid though. Probably other people would just type it in. What's the error here and why do I suddenly get an error here? Okay, I take it because Missing stuff. That's probably it. Okay, make. What? Compile. Energy is now up here. That's, I don't know if that is 50. I think it should be 50. And then it drops by 90%, I think. I think this belongs to the 1, so we hardly got any new energy. Now we go here, so we get this amount of new energy. So I would say that another 90% drop is probably here or something. And then plus that, so it should more or less become here. No, okay, 100% down. But yeah, we also have a 4 and a 5 added now, so I think it did a few more reductions. 90% reductions, plus reductions because we went uphill. It already went down. New LW is already 28 there. Not gonna work. And it's now 45. Well, it wasn't updated apparently. Oh, wait a minute, this was updated. Yeah, the kinetic energy is 45 because we are 45 below this maximum here. Yeah, might as well print the max height, but max height is drawn already. Now we have kinetic energy is 42. And then it would change to like 3 times. Yeah, okay. 25, 22, 17, 10. Really, there's no going. There's no another one yet. Energy's going out, energy's going down like here, I think. And the next step would be going over that. Well, I guess so. Yeah, what doesn't sit right here is that I reduce the energy with 90% every step, which is a tiny little step, and it loses 90% of its energy. And then this part is going, I don't know how much, and it's also losing 90% of the energy. That doesn't make any sense whatsoever. I think I should lose the energy that I should lose is 90% of the height difference. The absolute value of the traveled vertical distance. That would make much more sense. Which means that if it is rolling horizontally, then I would not lose any energy. Also not totally correct. You can more or less approximate it with a straight line, maybe. So just the square root of the square of this plus the square of that. But we can't really compare these dimensions. Well, you can, I can just take this and then divide that by the derivative. To get something that is indicative of the height. And then that's indicative of the energy, and 90% of that. Seems to make a lot of sense. Especially since I don't divide by anything, I just multiply by something. Or did it, I just said to divide, I guess. It should be divide. No. Huh? What? Yes. No. No, 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 no. Where's my piece of paper? Here's my piece of paper. Let's say we have this slope, and we have this distance, delta W. Then this height is obviously dl dw times W times delta W. Yeah, doesn't make any sense. It's not really friction, of course, so maybe I'm just maybe per step is good enough. I'm gonna do it. I think the whole idea is that well, no, it's theoretically a step though. I was going to say that I thought that the whole idea is, say, you start here, then you want to go down and then shoot through up till 90% of the previous height. That's basically the idea, I thought. Therefore, by the time I've gone down and then up again, I wanted to have reduced from 50 to 45. And I also think that it makes sense that I reduce it less if I make a little small step than when I travel a larger distance. So what if I just reduce the total energy or the maximum height that we can reach with 10% of the travel distance vertically, or even 5%, because I also go down. So I travel from 5 to 6 here, then actually it looks more like from 4 to 5. Then the vertical distance almost nothing, and then 10% of that is like a pixel. And then I just reduce this thing almost nothing. And then every time, and by the time I go from 8 to 9, 10% of that height is being subtracted, and so on. Therefore, by the time I go from here till where the thing is now, the thing itself has been reduced by that height, because that's all those adds, vertical adds, times 10%. So 10% down, so it is 90% of where it was. I think that seems to make a lot of sense, because then we reach 90% height, plus we reduce small steps, just reduce it almost nothing. So we are at a certain height, you go to a new height, and then the height difference times 1 minus eta should be subtracted from the maximum, which is again completely different than what I just did. It lasts like 2 hours. You guys, I think I'm going for a walk, because I'm sitting too much here. I think it's a good time to have a stretch my legs. I'll be back later.